First, let me use this diagram. This is the set A, this is another set B, this is our function G, 0, -1, 2, 4, 5, 8, 10, -11, half, 2, -2, Z, this is A, don't forget, say maybe 7, good. Now, suppose G takes 0 to A, takes -1 to 10, 2 to 11, 4 to half, 5 to -2. Now, this function G is a well-defined function. From set A into set B. So G is well-defined. But then, G is not surjective. That means it is not onto the codomain B. It's not surjective on B. Why is it not surjective? Remember, surjectivity says that if G is surjective, it means that for any element I take in B, there exists at least one element of A assigned to that element. If you observe here, 7 is a member of the set B, which is the codomain, but Z has nobody assigned to him. The same thing with 7. 7 belongs to this set, but there's nobody assigned to 7 from A. Therefore, this function is not surjective on B. Right. Let's define G from R to R plus by G of X is equal to X plus 2. The question is G surjective on R plus? Here, R plus is nothing but the interval 0, plus infinity. So to solve this problem, it suffices to take arbitrary value of this set and check whether we can get a real number such that when we add 2 to that real number, we get a G. If that is true, then that function is a surjective function. So we solve the problem. So we solve y, so we take y in R plus be arbitrary. Our goal is to find x such that we find x in the set of real numbers such that y is equal to x plus 2. But this is not difficult because we can always solve this equation very easy for x. So if this is true, this means y -2 is equal to x. So don't forget that we picked y first, so that when we subtract 2 from y, whatever we have is the x we are dealing with. So x here is a real number. And if we add x plus 2, are we going to get y? The answer is yes, because x plus 2 is equal to y minus 2 plus 2, which is equal to y. And that says that for any y we get, I simply take y minus 2 as my x. And so this function is a surjective function on x.